Let us evaluate the integral of cosine to the power of 11 of x. First up, check whether your exponent here is an odd or an even number. Since what we have here is an odd number, you must first factor out 1 cosine of x. Thus, this would be cosine to the power of 10 of x multiplied by the factored out cosine of x and copy the dx. Next up would be to transform what is left into its trigonometric identity. Sine squared of x plus cosine squared of x is equal to 1. This is the Pythagorean identity but for trigonometry. Since what we have here is a cosine, put sine to the other side, which makes this cosine squared of x be equal to 1 minus sine squared of x. What we have here is a cosine squared of x, so we must compress this, making this the integral of cosine squared of x. 10 divided by 2 would be 5, multiplied by cosine of x dx. Now that we have this, we can now transform it according to its identity. Next up would be to expand this expression first. But before that, for simplification, we must use U-substitution in here first. Let U here be sine of x now. Whenever you're doing a U-substitution, take the derivative. So du right here would be the derivative of sine of x, which is cosine of x, and multiply this by dx since it is respect to x. You can see here that cosine of x dx is the same as du. But if you want to be sure, just isolate dx here, which makes this dx equal to du over cosine of x. By that, we would have this value, the integral of 1 minus, since this is sine squared of x, it would be u squared raised to the power of 5 multiplied by cosine of x, and taking the value of dx, which is du over cosine of x. You can see here that cosine of x would cancel, which leaves you with a du in here. So this would be your value now. The next step would be to expand this expression now. What we have here is a binomial theorem to the power of 5. A minus b raised to the power of 5. The expression here would be, according to the Pascal triangle, a power of 5 would have the coefficients of 1, 5, 10, 10, 5, and 1. So for that, this would be 1 multiplied by the first variable, which is a to the power of 5, minus the next coefficient, which is 5. And for the first variable, it is descending, so this would be a to the power of 4. And for our second variable, which is b, it would be ascending, and so just add b here. Thus the sign here would be alternating, so this would be plus the next coefficient would be 10, a cubed multiplied by b squared minus 10 a squared multiplied by b to the power of 3 plus 5 a b to the power of 4 minus 1 multiplied by b to the power of 5. Since this would be our formula now, we can put a here as 1 and b here as u squared. So by the formula, just replace all of this. this would be the integral of 1 multiplied by a to the power of 5, which is 1, is simply 1 minus 5 multiplied by a to the power of 4. A again is 1, so just assume that all a values here are always equal to 1. Just focus on b. B here would be u squared plus 10 multiplied by 1 multiplied by b squared. U squared to the power of 2, it would be equal to u to the power of 4. Minus 10 multiplied by 1 multiplied by u squared cube would be u to the power of 6, and so on. Now that you have this, just copy now the du next. And now you can integrate this one by one via power rule. Let's start with this first. The integral of 1 du, it is equal to simply u. The integral of, wait, let me just put the coefficient first. The integral of u squared would be equal to u to the power of 3 over 3 plus the integral of u to the power of 4 would be u to the power of 5 over 5. Let me just make some space here. Just know that u here is equal to sine of x. I just rewrote this. Now let's move on. The integral of u to the power of 6 would be u to the power of 7 over 7, and so on. I think you get the pattern here now. And don't forget to add the constant of integration. Now that you have that, we can first simplify all our coefficient number here. So this would be u minus 5/3 u to the power of 3 plus 10 divided by 5 would be 2 multiplied by u to the power of 5 minus 10 over 7 u to the power of 7, and so on. For this one, I will just put 1 over 11 multiplied by u to the power of 11. It's just the same basically. Plus c. And for your final answer, just put u back into their original form. And so your final answer for the integral of cosine to the power of 11x would be sine of x minus 5/3 multiplied by sine cube of x plus 2 sine to the power of 5 of x minus 10 over 7 sine to the power of 7 of x plus 5 over 9 sine to the power of 9 of x minus 1 over 11 sine to the power of 11 of x, and of course, the constant of integration. I'm